Solve the differential equation cosine squared of x divided by e to the power of y minus e to the power of y dy over dx is equal to 0, given that y is 0 when x is pi, and then find the value of y when x is pi over 2. So to solve this equation, we try to separate variables. If you cannot separate variables, you should apply another method, some substitution or something else, and you should know that if dy over dx can be represented as a function of y over x, it should be solved using substitution. Y is vx, but here definitely dy over dx is not a function of y over x, and if equation is of the form it is given in a data booklet, so that it can be solved by integrating factor, but definitely it's not of that form. So let's try to separate variables. So move it to the right and multiply both sides by e to the power of y, and by multiplying both sides by dx, so we get the next, that cosine squared of x multiplied by dx is equal to e to the power of y multiplied by e to the power of y dy. So we can see that it is separated, variables are separated, hence we can integrate both sides. And on the left hand side we can see cosine squared. How to integrate cosine squared? Using a double angle formula. It is given in the data booklet, and cosine squared is 1 plus cosine of 2x divided by 2 dx integral, and is equal to, or actually let's integrate both sides and then we rewrite this. So this integral is equal to what? It's integral of a half, so a half integral of dx plus a half integral of cosine of 2x dx, which is just a half x, plus integral of cosine, it's a sine, but it's all 2x. In general, it's substitution u to be 2x, but if it's function of ax plus b, we apply formula given in a data booklet, but just 1 over a arises in front, so it's just this half and 1 over 2, because 1 over a half, and sine of 2x, and plus constant. And how to integrate e to the power y, e to the power of to the power of y dy? Definitely by substitution. So let this power or argument be u. So u is e to the power of y, then as usual we consider derivative du over dy, and it's just e to the power of y, hence dy is du over e to the power of y, hence our integral becomes e to the power of y. You may substitute by u, but it will cancel, so it doesn't matter. Oh, let it be u. So e to the power of u, and dy is du over e to the power of y, so you may write e to the power of y and it cancels, or it's if you write u here, u is also here, so you can see u cancels, and we get integral e to the power of u du, which is just e to the power of u plus some constant. And then our equation becomes the left hand side. So it's what, the half x plus 1 over 4 sine of 2x. We can write constant on the left hand side or on the right hand side, it doesn't matter, and it's enough on only one constant. And let constant be here, e is equal to, and e to the power of u, it's e to the power of y. So it's e to the power of y. And let's find constant. It is given a point, actually pi 0. So substituting pi 0, we get the next. So x is pi, so it becomes pi over 2 plus 1 over 4 sine of 2 pi plus constant is e to the power of 0, and it's e to the power 0, it's 1, so it's just e. And sine of 2 pi, it's 0, so constant becomes e minus pi over 2. So finally it becomes a half x plus 1 over 4 sine of 2x plus e minus pi over 2 is e to the power y. Notice that it's not required to represent the answer in the form y is. It's not specified. So we can give the solution of this equation like this, but it's not necessary, but you can solve for y and represent as y is. So let's solve for y. So definitely we should consider ln of both sides, and according to the property of ln, this becomes in front, so it becomes e to the power of y multiplied by ln e, which is 1, is equal to this ln. And then again applying ln, we get again y multiplied by ln e, which is 1, so it's y. So y is ln of half x plus 1 over 4 sine of 2x plus e minus pi over 2. Let's check. Yes, it's correct. And the next, find the value of y when x is pi over 2. So when x is pi over 2, x is pi over 2, y is ln of pi over 4 plus 1 over 4 sine of what, of pi plus e minus pi over 2, and it is equal to ln of sine of pi is 0, so it becomes e, and pi over 4 minus pi over 2, it's minus pi over 4. So it's as the exact answer, and it's a question with a calculator, so it can be calculated, and it's minus or negative 0.417 to 3 significant figures. So if it's specified the answer to be given as the exact value, so you should write like this, or If it's paper 2 question with calculator, you may calculate and find the value to 3 significant figures. And that's all for this question.